Okay, here's our part 2. We've got examples 4 and 5 coming. Okay, it says use a calculator to find the value of the trigonomic function to 4 decimal places. Okay, so we just want to make sure you know how to type this into your calculator. Well, as you can see through A, B, C, and D, okay, the first 2 are degrees and the second 2 are radians. All right, so you want to make sure that you're in the right mode on your calculator. So our mode button is right here. So we hit mode, right? And then right here is our radian or degrees. So the first 2, I'm going to be in degree mode, right? Which is highlighted, so that's good. To change it, I highlight it, press enter. Now it's in radian mode. Now it's in degree mode, all right? So cosine 21, and then it means that 21 is degrees. And then 4 decimal places, so 0.933, and then the 5, well, next one's an 8, so that's going to go up to 6. Okay, pretty simple one to start. All right, in B, all right, it's secant. Well, if you look at the calculator, sine, cosine, and tangent, no secant, no cosecant, no cotangent. So we have to convert this first. So secant 55 equals 1 over cosine 55, and that's a button we have. And so when I put it in, 1 divided by cosine 55, that's 1.743. Next one, this back one's a 4, so it stays where it is, 4. All right, for C and D, okay, now we don't have degrees, we have radians. So I go back to mode, and change my mode to radians, and now I'm ready for radians. So sine 3 pi divided by 10, so 0.8090. All right, and now we run into a cotangent. We don't have a cotangent button, all right? And so we can turn it into a tangent that's equal to 1 over tangent pi over 18. And that I can do. And so I have 1 divided by tangent pi over 18. 5.671 round up to 3. All right, last set of problems here. Example 5, we got some right triangles. I'm going to find the measure of the side of the right triangle whose length is designated by a lowercase letter. Round answers to the nearest whole number. Okay, so here's our little lowercase a, opposite of a. And so we're back to our, it's pretty small, I don't know if you can see that. Back to our SOHCAHTOA for right triangles. All right, so here's my angle. I need opposite, and I know adjacent. So opposite and adjacent is tangent. So tangent 61 equals opposite over adjacent. Right? Now to get a by itself, we'll multiply both sides by 10. And so 10 times tangent 61 equals a. Back to my calculator. Now we were just in radian mode before, so we got to change. We'll go back to degree mode. 10 times tangent 61. And it says round to the nearest whole number. So we'll say that a is 18. I guess we should write centimeters. All right. B, same idea. Here's my 34. Opposite hypotenuse. There's opposite hypotenuse, sine. So sine 34 equals opposite over hypotenuse. Multiply both sides by 13. So 13 sine 34 equals a. So take it to my calculator. 13 sine 34. Nearest whole number is going to be a 7. All right. C down here. Here's my 44. All right. Opposite, adjacent. So we're back to tangent. All right. So tangent 44 equals opposite over adjacent. All right, so this one's a little bit different than A because the variable's in the denominator. All right, so what I'm going to do, put tangent over 1, cross multiply. So B times tangent of 44 equals 1 times 23. And now I can divide by tangent of 44. And B equals 23 over tangent of 44. And put that into my calculator. 23 divided by tangent 44. Nearest whole number will go up. And so I'll call it 24.